So for in-class question 1, we're taking the same data from in-class question 2 from lecture 5. So we have a wheelbase, L is 2.438 metres. Okay, we've got a speed, V, of 60 miles per hour, which we know is 26.8224 metres per second. Okay, and we determined from that question that Ku, the understeer gradient, was 0.0403 degrees per metres per second squared. And the question is, what is the lateral acceleration gain? So, obviously, we have an equation for this. Ay of a delta, which is the lateral acceleration gain, is v squared divided by 57.3 L divided by 1 plus Ku v squared divided by 57.3 L. And if we plug in the numbers, so that's going to be 26.8224 squared divided by 57.3, 2.438 being L, divided by 1 plus 0.0403, 26.8224 squared divided by 57.3, 2.438. So if we bring up the calculator, 26.8224, 57.3, 2.438. Okay, that's the numerator. And on the bottom we've got 1.0403, 26.8224 squared, 57.3, add them together, divide. We have 4.265 meters per second squared per degree. This means for every additional degree of steer angle would introduce another 4.265 meters per second squared of lateral acceleration. For in-class question 2, we have the same problem as for in-class question 3 from lecture 5. So we have the same wheelbase, 2.438 meters. We have the same velocity at 60 miles per hour, which we know is 26.8224 meters per second. Ku, though, is different this time. It's minus 0.0451 degrees per meters per second squared. And so the lateral acceleration gain in this case, v squared over 57.3 L divided by 1 plus Ku v squared over 57.3 L. So let's plug in the numbers, 26.8224 squared divided by 57.3, 2.438 divided by 1 plus minus 0.0451, 26.8224 squared divided by 57.3 times by L, 438. And if we do that sum, so 26.8224 squared, 57.3 57.3 divided by 38 divided by, and then we've got 1.0451 8224 squared times 57.3 2.438. Add that to 1. Divide. So we get 6.708. 6.708 meters per second squared per degree. Remember in these cases that the steer angle was very small, so 1 degree of an additional steer angle would be quite a big change. I think for the ICQ1 the steer angle was 0.675 degrees, so that would make sense for it to be quite a significant change in lateral acceleration with an additional degree, a whole degree of steer angle. Think class question 3. We're asked to find the yaw rate and yaw velocity gain for the same data that we had for in-class question 1. So L is 2.438, V 26.8224 meters per second, which is equivalent to 60 miles per hour. We've got a corner radius of 250 meters, and we've got a understeer gradient of 0.0403 degrees per meters per second squared. Okay, so the yaw rate, that's given by R, which, if we were to look at the question, is 57.3 V over big R. So 57.3, 26.8224 divided by 250. So again, a simple sum, 57.3, 26.8224, 6.148. There we are. That's what I meant. So that's your rate, your velocity gain. Okay. So that's going to be R divided by delta, and this is V upon L divided by 1 plus KU V squared over 57.3 L. And so we've got 26.8224 divided by L, which is the wheelbase, 2.438, divided by 1 plus 0.0403, 26.8224 squared divided by 57.3, 2.438. So again, 26.8224, 2.438. Okay, there's the numerator. We have 1.0403, 0.8224 squared, 57.3438. Add that to the 1. Divide. We have 9.11. 9.111. Okay, and that's degrees per second over degrees, so that's per second. S to the minus 1. Same class question 4. Same question, except this time we've got KU being minus 0.05451 degrees per meter per second squared. And so we've applied the same equation. So R, which is the yaw rate, that makes no difference. That's exactly as before. That's 6.148 degrees per second. However, the yaw velocity gain is different, so with a different value for Ku. So that's V divided by L divided by 1 plus minus 0.0451, 2.438 divided by 57, that's 2.438, 26.8224 squared, 57.3 times by 2.438. So again, let's go through 26.8224 divided by 2.438, and then we've got 1.0451 minus 26.8224 squared. We'll put them together, 57.3, 2.438, add that to 1, divide, we have 14.330, and again that's seconds to the minus 1, because we've got degrees per second on top and degrees at the bottom. Okay, so those are the values for the yaw velocity gains for for question 3 and question 4. And this means that for an additional degree of steer angle, we get an additional yaw of 9.11 degrees per second for question 3, and for question 4, for an additional degree of steer angle, we get an additional yaw of 14.33 degrees per second. This is question 4 is an oversteering car, so that would make sense if you think about it. If you increase the steer angle, you'd get more of the vehicle yawing, because the back tyres are sliding more than the front tyres in a sense.